Hello and welcome to our channel. Have you ever wondered why everything falls down and not up? What compels objects to fall towards the earth? This mystery, friends, is the enigma of gravity. Gravity, a fundamental force of nature, is the unseen puppeteer that choreographs the motion of all objects, from the smallest speck of dust to the mightiest of planets. It's this force that tugs at everything, pulling it towards the center of the earth. Picture an apple falling from a tree. It doesn't float away into the sky, but instead it descends towards the ground. This is gravity at work. Gravity is not only responsible for the fall of an apple, but it also keeps our feet planted firmly on the ground and the earth in its orbit around the sun. It's this invisible force that ensures the cosmos dances to its tune. So gravity is the unseen force that keeps our feet firmly on the ground and causes objects to fall. Now that we understand gravity, how does this force influence the fall of objects? Gravity, the invisible puppeteer, pulls everything towards the center of the earth. It's a constant force that never lets go. Now, when we think about falling objects, we must consider gravity's role in this process. Imagine dropping a feather and a stone in a vacuum, a place devoid of air or any other matter. Though the feather is lighter and the stone heavier, they would hit the ground at the same time. This might seem counterintuitive, but it's a fundamental truth of physics. This principle, first demonstrated by Galileo, holds that all objects, regardless of their mass, fall at the same rate in a vacuum. The force of gravity acting on an object is its weight. In our feather and stone example, gravity pulls harder on the stone due to its greater mass. However, the stone is also harder to move because of this increased mass. These two effects cancel out, making the feather and the stone fall at the same rate. But wait, you might be thinking, I've seen a feather and a stone fall, and the feather definitely doesn't hit the ground first. And you'd be right. In the real world, we're not in a vacuum. We have air, and with air comes air resistance. Air resistance, or drag, is the frictional force air exerts against a moving object. As objects fall, they push air out of the way. The more surface area an object has, the more air it needs to move and the more air resistance it experiences. So in the real world, a feather, with its larger surface area compared to its weight, experiences a lot of air resistance, causing it to fall slower than a stone. Thus, the fall of an object is not just a simple drop. It's a fascinating dance with gravity and air resistance, a performance that plays out every time you drop something, whether you're aware of it or not. Gravity, it's almost like an invisible puppeteer controlling how objects move and interact. But how does it do it? Let's delve deeper into this fascinating phenomenon. Gravity is a force of attraction that exists between any two masses, any two bodies, any two particles. It's this force that keeps us grounded on Earth, prevents the moon from hurtling off into space, and keeps the planets orbiting around the sun. The strength of this force is directly proportional to the product of their masses and inversely proportional to the square of the distance between their centers. This is the essence of Newton's law of universal gravitation. However, the story of gravity doesn't end there. Enter Albert Einstein with his theory of general relativity, which takes us a step further. According to Einstein, gravity is not just a force, but a curvature in the fabric of space and time caused by mass and energy. Imagine a rubber sheet stretched tight. If you place a heavy ball on it, the sheet will bend around the ball. This is how mass warps space-time. Now, if you roll a smaller ball close to the heavy one, it will fall towards it, not because of a mysterious force pulling it, but because the path it follows is curved by the heavy ball. In this way, gravity is akin to the contours of a landscape guiding a river's flow. We can see this effect on a cosmic scale. Massive objects like stars and galaxies bend the space around them, causing light to follow curved paths and making distant galaxies appear distorted. This phenomenon, known as gravitational lensing, serves as a powerful confirmation of Einstein's revolutionary theory. In essence, gravity is the silent director of the cosmic ballet, guiding the movements of everything from the smallest speck of dust to the largest galaxy. It's a force that's ubiquitous yet invisible, simple yet complex, and without it, the universe as we know it would simply fall apart. Gravity, then, is not just a force, it's a fundamental part of our universe. But what have we learned today? We've delved deep into the enigmatic nature of gravity, a force that, despite being invisible, holds an omnipresent sway over everything in our universe. It's not just a phenomenon, it's a cosmic choreographer, dictating the movements of celestial bodies and the tiniest particles alike. Our exploration took us through the science of falling objects, a seemingly simple concept that echoes the complexities of gravity itself. We saw how gravity doesn't just pull objects toward the Earth. It's an intricate ballet, where the mass of the objects and their distance from each other determine the speed and direction of their fall. We also discovered how gravity, the invisible puppeteer, pulls the strings in our universe. It's gravity that keeps us anchored to the Earth, sets planets orbiting around stars, and even bends the very fabric of space-time itself. It's a force that is both constant and changing, a paradox that continues to fascinate and baffle scientists. We've also touched upon the counterintuitive nature of gravity. It's a force we can neither see nor touch, yet we can observe its effects everywhere. From the apple falling from the tree to the moon circling the Earth, gravity is the unseen hand guiding the symphony of the cosmos. Finally, we've seen that understanding gravity is not just about comprehending a physical force. It's about appreciating the intricate dance of the universe, the delicate balance that keeps everything in motion. It's a testament to the intricate and interconnected nature of our universe, where even the smallest changes can have far-reaching effects. So, as we conclude our journey, let's take a moment to marvel at the unseen force that shapes our world and our universe. Gravity is not just a scientific concept, it's a fundamental part of our existence, a silent conductor orchestrating the cosmic ballet. As we've seen, gravity is an unseen force that shapes our world and our universe. So the next time something falls, remember, it's not just falling, it's dancing with gravity. Thank you for watching, and we'll see you in the next video.